Let's have a look at outliers now. An outlier is an unusually small or large score, but the problem is there's lots of ways that you can work out whether a score really is big or small enough for you to call it an outlier. So what are some of the methods that are used? Well, you might look at the size of the gap between it and the other scores. You might see how far it is from the mean or how far it is from the median. One that's used really commonly is to look at whether it's more than 1.5 times the interquartile range above or below Q3 or Q1. Now, thinking about what that might look like, on a box and whiskers plot, an outlier is likely to be the highest or the lowest score, or one that is exceptionally high or low. Now, if you were to say, is it more than 1.5 times the interquartile range, remember that the interquartile range is this big. And so if you've got a score sitting more than 1.5 times that, in other words, more than this big above or below, then you're going to say, hey, that's really big or really small, by the way. So in this case, you probably wouldn't say there's any real outliers. This score is small, but it's only less than one lot of the interquartile range away from the Q1, isn't it? So it's not really that small. Whereas if you had a score that was really, really big, you'd say, look, this score is a long, long way above the Q3. It's more than 1.5 times the interquartile range away. Does that sort of make sense? Now, the problem though is that none of these actually take into account the size of the sample or the likelihood of such a score occurring. And that's actually a problem. And that means that we should use any of these things with caution. Now, having said that, this last one is worth remembering. Is it more than 1.5 times the interquartile range? I should write in there above or below the Q3. I've just been a little bit lazy referring to that one. That one's worth remembering because we do use that sometimes in textbooks. You might see it in a question, but just remember that we need to use it with caution. Now, why would you use it with caution with a small sample size? Well, let's imagine we went into our kindergarten class in a school and we measured everybody's height. And perhaps most of the kids just happen to be pretty short in that class for whatever reason. Maybe there's not many of them. We might come up with some data about what we think is a really normal height for kindergarten children based on that really small size sample. And there might be one kid in there who's a lot taller than the rest, and we might claim, he's a giant, he's such an outlier, he's huge compared to the others, he might be, way off the chart. But remember, if we're only looking at 20 children, it might just be that most of them happened to be short, and what we thought was normal was actually a little bit below normal. If we then measured every kindergarten student in the state, we'd have a much better idea of what's normal and what isn't. And we might then find that actually the median is a lot higher than we thought that it was. And that kid that we thought was a giant is actually, yes, tall, but not as far above the average as we realised. So that's why we have to use this one with a bit of caution. It doesn't take into account how many people we've looked at. And of course, the more people we look at, the more we can infer what the likelihood is of somebody being that tall or that short in that example. Because if you've tested a lot of people and there was only one person that was way above the others, you know that's very rare. Whereas if you've only tested a small number of people, you can't really tell whether being that short or tall is common or not.